We live on a planet we barely know, a world of light and land, of wind and stone, but beneath it all lies another Earth. It moves to its own slow rhythm. It breathes with unseen weather. It remembers everything. We call it the ocean, but that word is too small for what it truly is. Because this is not just water, it's the living bloodstream of the planet, a vast fluid world that shaped every breath, every storm, every heartbeat in the history of life. From space, it looks like infinity, a single body of blue hiding the greatest wilderness we've never seen. Before there was land, there was water. Before there was life, there was the sea. It created us, it sustains us, and it will outlive us. This is the ocean, Earth's last frontier. More than 70% of our world is covered by it. It holds 97% of all water on Earth and drives nearly every process that sustains life above the waves. The rain that fills our rivers, the air we breathe, the clouds that cradle continents, all begin with the sea. We often call space our final frontier, yet the greatest unexplored realm is the one surrounding us. We've mapped the surface of Mars in higher resolution than our own ocean floor. We've sent probes beyond the edge of the solar system, but still, less than 5% of Earth's seabed has been seen, let alone understood. Every sonar scan, every descent, every sample taken from the depths reveals something that challenges what we thought we knew about our home. The irony is profound. In our search for other worlds, we've overlooked the alien world beneath our feet. To the earliest explorers, the ocean was infinite, a mystery stretching past the horizon. Its depth was a myth, its creatures, superstition, its power, divine. Today, science has replaced myth with measurement, but even now the sea resists definition. It's too vast, too dynamic, too alive to be reduced to data points on a map. The ocean is not one uniform body. It is a collection of systems layered and intertwined, a living machine made of currents, temperature, chemistry, and life. And within that complexity there is balance, a constant negotiation between heat and cold, carbon and oxygen, light and darkness. It is both cradle and climate engine, both destroyer and saviour. The ocean shapes everything it touches. Over millions of years it sculpted the continents, ground down mountains, and carried their dust to form new land elsewhere. It wrote the coastlines that define our geography, and built the atmosphere that allows us to breathe. Even now, the ocean regulates the global thermostat. It absorbs and releases heat, controls rainfall and drought, and determines the strength of storms. Every breath of wind that crosses a city, every drop of rain that falls on a forest, begins as an idea whispered by the sea. And yet, for all its power, the ocean remains strangely invisible. We live alongside it, travel over it, extract from it, and rely on it completely, but we rarely see it as a world in its own right. The surface is all most of us ever know, a glittering skin of reflected sky, a shifting mirror of weather and light. But beneath that thin boundary lies a place as foreign to human experience as the surface of another planet. A single drop of seawater can contain more than 1 million living organisms. Each one, plankton, bacteria, larvae, is a tiny engine in a vast planetary network, recycling nutrients and capturing sunlight to feed the world above. Collectively, these microscopic drifters produce over half the oxygen in our atmosphere. Every second breath you take came from the ocean. We tend to think of the ocean as empty, but it's the most biologically active region on the planet. From its surface to its deepest trench, it sustains forms of life so diverse and so specialized that entire ecosystems can exist within a single cubic meter. To understand Earth is to understand that the ocean is the planet. The continents are interruptions islands in a single interconnected sea. Our species has spent centuries trying to chart this water world. The first oceanographers dragged weighted lines from sailing ships to measure depth. The Challenger expedition of the 1870s crossed the globe cataloguing species no one had imagined. Since then, submersibles, satellites and sonar arrays have deepened our perspective, but not our mastery. The deeper we look, the more the ocean confounds us. At the surface, sunlight drives motion. Wind pushes waves that transfer energy across thousands of kilometers. Beneath them, temperature and salt govern density, the forces that steer the great currents linking every sea. These invisible rivers of water shape climate and life everywhere they flow. They connect the Arctic to the tropics, the Atlantic to the Pacific, and the atmosphere to the land. The ocean, in this sense, is not just part of the planet, it is the planet's circulation, its bloodstream. But there's another kind of current that flows through the sea: time. Every layer of sediment, every trapped bubble of gas, every chemical trace preserved in the deep records the history of the world. In the ocean's depths, time moves differently. The water itself can be centuries old, formed at the poles, sinking into the abyss, and only now returning to the surface. To study the sea is to read the biography of Earth, written in waves instead of words. Perhaps that's why the ocean still feels so mysterious. It's not simply that it's unexplored, it's that it operates on scales beyond human intuition. We measure time in years and generations. The ocean measures it in cycles and epochs. We live by sight and air. The ocean exists by pressure and flow. It is not hostile, only indifferent. And in that indifference lies a kind of purity, a reminder that Earth is more than habitat. It's an organism, vast and alive, and we are part of its respiration. The story of the ocean is not one of discovery, but of perspective. Each expedition, each dive, each new dataset pulls back a veil, revealing that the ocean is not just the background of life, but its foundation. Everything we know, everything we depend on began here, and everything we do still returns here. This is where the story begins, not with what we build upon the land, but with the water that built the land itself. Because to understand the future of Earth, we must first descend into the world we've barely begun to see. The first thing we see when we look at Earth from space isn't land or clouds or cities. It's blue, a colour so deep and dominant that it erases everything else. Our planet is not a world of continents surrounded by ocean, it's a world of ocean decorated with continents. From orbit, the ocean is alive with motion. Swirls of turquoise mark coral reefs and continental shelves. Dark gyres twist across the mid-latitudes like slow-turning gears, and along the equator, a shimmering belt of cloudless calm marks the place where the planet breathes out. What looks like stillness from above is, in truth, constant movement, the circulation of heat, water, and life. Every gust of wind across the surface transfers energy into the sea, sculpting waves that roll across thousands of kilometers. Some will travel halfway around the planet before breaking against a shore. Others will merge and collapse, disappearing back into the body of the ocean that made them. Each wave is born, lives, and dies, in a matter of seconds, yet collectively, they shape the face of every coastline on Earth. The ocean's surface is only a few millimeters thick, but it is the boundary that connects everything below to everything above. It's where sunlight meets seawater, and where invisible gases pass in and out of the atmosphere. Carbon dioxide dissolves here, oxygen escapes here. This thin film regulates the chemistry of the air itself. In every sense, it is the skin of the planet. Beneath that skin, light penetrates only about 200 meters, a fragile layer scientists call the photic zone. Within this narrow band of brightness, life explodes in diversity and abundance. Tiny drifting plants known as phytoplankton capture sunlight through photosynthesis, using it to convert carbon dioxide into oxygen and sugar. They are so numerous that they can be seen from space, colouring entire ocean basins in swirls of green and gold. These microscopic organisms form the foundation of the marine food web, feeding everything from krill to whales. Collectively, they generate more than half the oxygen in Earth's atmosphere. Every second breath you take is thanks to them. But the ocean surface is not just a biological wonder, it's a physical one. Sunlight warms the upper layers unevenly, creating gradients in temperature and density. Where warm and cool waters meet, currents form. These currents act like conveyor belts, moving heat across the planet. Warm water from the tropics drifts toward the poles, while cold water from the poles sinks and returns along the seabed. This global circulation is Earth's climate engine, distributing energy with quiet precision. The ocean doesn't just absorb heat, it moderates it. Because water holds vast amounts of thermal energy, it buffers the planet from extremes. The difference between a frozen world and a habitable one is measured in the ocean's capacity to store warmth. When the sea warms, the air follows. When the sea cools, the winds and clouds respond. Every storm, every drought, every gentle breeze begins as a whisper between ocean and sky. The living surface is also the world's meeting place. Here, life from the deep mingles with life from the air. Flying fish leap from waves to escape predators. Seabirds dive like arrows into the glittering schools below. Whales breach through the boundary, pulling the unseen ocean into view for just a moment before vanishing again. This is where the lines between worlds blur, where the ocean reminds us that air and water are just different states of the same cycle. Yet this delicate equilibrium is constantly tested. Wind, temperature and salinity form a dynamic balance that can shift with even the smallest change. When polar ice melts, it dilutes surface salinity, altering the density of seawater and slowing major currents. When surface waters warm, they expand, raising sea levels. When the air absorbs more carbon dioxide, the ocean follows, forming carbonic acid that dissolves coral reefs and shellfish. The skin of the planet is sensitive, and it responds to our every action. Despite this fragility, the ocean is resilient. Its systems are self-correcting on timescales much longer than our own. A single current may take 1,000 years to complete its loop around the world. To the ocean, human centuries are brief fluctuations, but even resilience has limits. When pressure is applied faster than the system can respond, change accelerates, and equilibrium becomes something new. It's easy to think of the ocean's surface as familiar. We sail it, swim in it, look out over it from our cities and coasts. But this is not the ocean we truly live with, it's only the ocean we can see. Beneath the waves lies another realm entirely, where light becomes memory and colour fades to blue, then to black. It's a descent not just into water, but into time. Pressure increases, temperature drops, and the physics of survival shift into new territory. For most of human history, we thought of that deep world as lifeless, a cold abyss too hostile for biology. But we were wrong. The truth is far more extraordinary. In the depths below the living surface, life has adapted to the impossible. There in the darkness it glows. It stretches, compresses, and bends the very rules of existence. To enter the deep ocean is to enter a place that redefines what it means to be alive. And that is where we go next, down into the twilight, through the silence, into the heart of the unknown. To descend into the sea is to leave behind the world as we know it. Every metre downward feels like moving through time backward, away from the familiar into the deep history of the planet. Light fades quickly in seawater. Within just a few dozen metres, red disappears, then orange, then yellow, until only blue remains. Below 200 metres, even that vanishes. Here begins the ocean's twilight zone, the Mesopelagica realm between day and night, where sunlight flickers but never truly arrives. The pressure rises with each descent 1 atmosphere for every 10 metres. At 1,000 metres, it's 100 times greater than at the surface. Metal creaks, air compresses, even sound changes character, moving faster, sharper, like a vibration through glass. In this perpetual dusk, light becomes currency. Creatures that live here have evolved to make their own. Tiny lanternfish drift in vast shoals, each dotted with photophores, organs that glow like stars. Siphonophores, jelly-like colonies stretching dozens of meters, shimmer in pulses of green and blue. Bioluminescence is communication, camouflage, and lure the language of the deep. A single flash can mean danger. A faint glow along the belly of a fish can erase its shadow, making it vanish against the faint light above. To human eyes, this world feels alien, but to the species that inhabit it, it is the center of existence. Life here follows an ancient rhythm. Every night, when surface waters cool and darkness falls, billions of creatures migrate upward from the twilight zone to feed. They rise silently, forming a vast invisible tide of life. Just before dawn, they sink again, carrying carbon and nutrients into the deep ocean. It is the largest migration on Earth, a movement so immense it influences the global carbon cycle. And it happens every single night. As we descend further, light fades entirely, This is the midnight zone, the bathed Pelagica realm of total darkness, stretching from 1 kilometre down to 4. No sunlight has ever touched this place. Here, pressure is immense, temperatures hover near freezing and food is scarce, yet even here life endures. The animals of the midnight zone are built from compromise, their bodies soft, their metabolism slow, their senses sharpened in ways we can barely imagine. Some, like the anglerfish, carry lures of living light, dangling bioluminescent bait before jaws lined with transparent teeth. Others, like the vampire squid, drift with outstretched arms covered in photophores, creating a living constellation of defence. There are species that have no pigment, no eyes, and others whose eyes are enormous, designed to capture even the faintest glimmer from above. In this darkness, survival depends on efficiency. Energy is precious, movements are slow, encounters are rare. Predators and prey exist in equilibrium, each adapting to the other in an endless evolutionary dialogue. Occasionally we find reminders that the surface still matters here. Marine snow, a gentle rain of detritus, plankton and decaying matter, drifts endlessly downward. It is the deep ocean's lifeline, feeding creatures that will never see sunlight. When that snow reaches the seafloor, it accumulates into layers that hold the memory of ages' chemical archives of ancient climates, volcanic eruptions, even mass extinctions. The ocean's floor is not dead ground. It's a slow-moving library, preserving everything the world forgets. At around 4,000 metres, the bottom appears a vast plain stretching farther than any desert. This is the abyssal zone. The temperature never rises above 2 degrees Celsius. There are no seasons, no day or night. Only the slow drift of silt and the faint vibration of distant tectonic motion. And yet, life continues. Sea cucumbers inch across the sediment, filtering nourishment from the dust. Brittle stars extend their arms to catch invisible currents. Even here, miles beneath storms and sunlight, the biological pulse of Earth continues to beat. Occasionally the monotony of the abyss is broken by vents, fissures where seawater meets molten rock. Superheated fluids surge upward, carrying metals and chemicals that crystallize into towers and chimneys. Around these vents, life flourishes in total darkness, drawing energy not from the sun but from the Earth itself. Here, bacteria harness hydrogen sulfide, fueling entire ecosystems of worms, crabs and clams. When scientists first discovered these vents in 1977, they realized they had found something profound, life powered by geology. A reminder that biology and planet are not separate systems, but one continuous cycle of energy and adaptation. Below even this, where the ocean trenches cut into the crust, lies the Hadal Zone, the true abyss, named for Hades, the underworld. In these trenches, the water column can reach 11 kilometers deep. The pressure is so extreme that most materials would collapse instantly. For decades, scientists believed life couldn't exist there. Then cameras were sent down and moving shapes appeared on the screen. Translucent snailfish, amphipods and shrimp-like creatures drifted calmly among the rocks, perfectly adapted to their impossible world. They don't see the ocean as hostile or alien. To them, it's normal, the only home they've ever known. Every descent we make into these depths forces us to reimagine what life can be. Creatures here metabolize differently, reproduce differently, and age at different rates. Their existence challenges the limits of physics and biology, proof that life is not fragile but relentless. Even in this silence, the ocean is moving. Currents creep through the trenches, whispering across continents. Sediment slides like slow avalanches. Earthquakes send vibrations echoing through the water. The deep is not still, it breathes, just in a slower rhythm than our own. In its darkness, the ocean holds a strange kind of peace, a stillness that is not absence but balance. The creatures of the deep are not reminders of how far removed this world is from ours, but how closely tied we are to it. The oxygen in our lungs, the climate that sustains us, the stability of our planet, all are anchored in this hidden world. The deep sea is not a graveyard. It's the foundation of life on Earth, a vast, silent engine that has turned without pause for billions of years. And even now it continues to turn slow, unseen, essential. Every moment of every day the ocean moves, not with the chaos of waves or tides, but with the steady persistence of a planetary heartbeat. water formed in the cold, dark polar seas sinks, sliding along the seafloor, creeping across entire ocean basins before rising again thousands of kilometers away. It's called the Global Ocean Conveyor Belt, a slow continuous circulation that connects every ocean into one single, moving system. This circulation is driven by density, by temperature and salt. Warm, fresh water is lighter and floats near the surface. Cold, salty water is heavier and sinks. Where the two meet, they mix and begin a journey that can last 1,000 years. A drop of seawater formed today in the North Atlantic might not resurface until the next millennium, emerging somewhere in the Pacific as part of the cycle's return. The scale of this system is difficult to imagine. It transfers heat around the planet, carrying warm water from the tropics toward the poles, and returning cold water back again. It is why the coasts of Western Europe remain temperate even at high latitudes, and why tropical oceans stay relatively stable despite the constant blaze of sunlight. The conveyor is the ocean's method of balance and equalizer that keeps extremes in check, but it is more than just a transport of heat. It is also the circulation of life. The upwelling zones where deep waters rise are some of the most productive ecosystems on Earth. As old water returns to the surface, it brings with it the nutrients of ages: nitrogen, phosphorus, and iron, recycled from countless generations of marine snow that fell into the depths. These nutrients fuel blooms of plankton, which feed fish, whales, and seabirds, supporting the entire oceanic food web. From the air, this cycle is invisible, yet satellites can see its fingerprint spirals of phytoplankton tracing the paths of currents, temperature gradients glowing faintly in infrared, vast eddies spinning like the slow gears of a clock. To study them is to study time itself. The energy that drives these currents is sunlight, wind, and the rotation of the Earth, all acting on a scale so immense that the human mind can only grasp them through analogy. Imagine a single breath moving through the lungs of a planet. That is the thermohaline circulation. At the surface, winds sculpt patterns we recognize. The trade winds pushing equatorial waters westward, the westerlies driving mid-latitude gyres, and the polar easterlies spinning the Arctic and Antarctic currents. Together they generate a continuous motion that binds the atmosphere and ocean into one system. Weather does not begin in the sky, it begins here, in the slow exchange of heat between air and sea. When warm surface water evaporates, it leaves salt behind, increasing the salinity of what remains and helping it sink. When polar ice forms, it rejects salt, creating dense brine that plunges downward like liquid gravity. When the ice melts, it freshens the surface, lightening it, slowing the great sinking currents. In this way, the cryosphere, the world's frozen water, acts as a throttle for the entire planetary engine. Too much melting and the engine slows, too much freezing and it accelerates. The balance is delicate, and in recent decades, we have begun to notice its tremors. The modern ocean absorbs over 90% of the excess heat trapped by greenhouse gases. This has consequences. Warm water expands, raising sea levels. Temperature gradients shift, altering the paths of major currents. In the North Atlantic, scientists are watching for signs that the deep water formation driving the conveyor may be weakening. If it slows significantly, weather patterns from monsoons to jet streams could shift. The ocean that stabilizes life could just as easily rewrite its climate. Even so, the ocean's capacity for resilience is extraordinary. Its chemistry adjusts, its circulation reorganizes, its biological systems adapt. The same water that once cycled through prehistoric seas still moves through the basins today, altered but enduring. To the ocean, our age is a moment of brief warming, a temporary imbalance in a story 4 billion years long. The engine does not stop, it changes rhythm, and within that rhythm, everything alive finds its place. Currents sculpt coastlines and carry larvae across oceans, connecting ecosystems separated by continents. They deliver nutrients that bloom into coral reefs, oxygenate the abyss, and ventilate the entire biosphere. The very sound of waves breaking on a shore is energy born thousands of kilometers away, translated through this great machinery. To understand the ocean's circulation is to understand that motion is not noise, it is memory. Each current carries information: heat from past seasons, chemistry from ancient volcanoes, sediments from forgotten rivers. It is a planetary archive in constant motion, rewriting itself endlessly, but never erasing what came before. We live inside the consequences of that motion. Our agriculture, our weather, our civilizations depend on patterns set by water we will never see. The same ocean that shapes hurricanes also sustains the monsoons that feed billions. The same circulation that cools the poles warms the fields where we grow our food. We are not separate from this system, we are expressions of it. Sometimes we speak of the ocean as though it were a mechanism, a machine of physics and chemistry. But that language misses something. The ocean's engine is not mechanical, it's biological, geological and atmospheric all at once. It is life in motion, self-balancing and self-correcting, the beating heart of a living planet. And as that heart continues to pulse, it shapes not only the weather and the seasons, but the boundaries of possibility for every form of life on Earth. The same currents that connect continents also connect time. The water rising at the surface today may have been last exposed to the sky during the fall of ancient civilizations. When it rises again centuries from now, it will carry the imprint of our age, a record of our choices written into its temperature and chemistry. The ocean remembers, and its memory will shape the world yet to come. Every coastline on Earth is a collaboration between water and time. The sea never rests, and across billions of years it has carved the shape of continents, built mountains, and erased them again. It is the great sculptor of the planet's surface, and the keeper of everything that surface has ever been. The ocean is not the opposite of land, it's the reason land exists. Long before mountains rose, long before continents drifted apart, the ocean was already at work. Rain, rivers and tides eroded the early crust, grinding rock into sediment that the sea reclaimed and compressed into new layers of stone. Those layers, buried and heated, became the foundation of continents. Land was born of the ocean, and in the end it will return to it. Each grain of sand carries the memory of this cycle. Fragments of ancient rock that once formed mountains, ground down by wind and rain, carried by rivers to the coast, then rolled and polished by waves until they became part of the shore. What we call a beach is simply time made visible. Stand barefoot at the edge of the sea and you are standing on the remains of the worlds long gone. But the ocean doesn't only shape the land, it shapes the air itself. Billions of years ago, photosynthetic microbes in the sea began releasing oxygen as a byproduct of their metabolism. At first, that oxygen reacted with dissolved iron, staining the ocean rust red. Only when those iron stores were exhausted did oxygen begin to accumulate in the atmosphere. The blue sky we see today is, in a sense, an oceanic creation, the breath of an ancient sea made visible. Even now, the ocean continues to write the atmosphere's chemistry. It absorbs roughly a quarter of all carbon dioxide we emit, dissolving it into a vast reservoir that buffers the climate, but also changes the sea itself. When carbon dioxide reacts with water, it forms carbonic acid, which gradually reduces the ocean's pH. This process, ocean acidification, weakens coral skeletons and shellfish shells, subtly altering the architecture of entire ecosystems. The ocean is both absorber and victim, healer and witness. In its depths, it records these changes. Layers of sediment on the seafloor form a continuous timeline of Earth's past. Every eruption, every extinction, every shift in climate leaves a signature in those layers: volcanic ash, microfossils, isotopes of oxygen and carbon. When scientists extract cores from the seabed, they are reading a diary millions of years old. The rise and fall of temperatures, the cycles of ice and warmth, the traces of mass extinctions, all are there, preserved in grains of mud. These archives reveal a profound truth. The ocean has always been the author of renewal. Every catastrophe on land asteroid impacts, volcanic winters, global ice ages has been followed by recovery, and that recovery has always begun in the sea. When life was nearly erased, it was the ocean that sheltered what remained. From those survivors, evolution began again. The story of life is written in the tides. The earliest multicellular organisms arose in shallow marine shelves, where waves and sunlight met. Fish evolved there, developing the first backbones. Eventually some left the water, breathing air and walking on land, but even in us the ocean remains. The saline composition of human blood matches that of ancient seawater. The rhythm of our hearts echoes the tides. In a biological sense, we never truly left the sea, we carried it with us. But if the ocean creates, it also destroys. It is capable of both gentle erosion and sudden violence. Storm surges, tsunamis, and rising tides reshape coasts in moments. Yet even in destruction, there is creation. Coral reefs grow from the skeletons of previous generations. Deltas form from floods, and new shorelines emerge where old ones fall away. The ocean's artistry is not permanent, it's perpetual. And just as it shapes the physical Earth, it shapes its climates. The interplay of evaporation, condensation, and rainfall forms the planet's weather systems. When warm ocean water evaporates, it feeds clouds that travel thousands of kilometers, releasing their rain over distant lands. The moisture that falls in forests, on farms, and on cities all begins in the ocean's invisible breath. Even deserts are touched by it, their winds, their seasonal changes. Their very existence depend on the ocean's control of heat and air. Without the ocean's stabilizing presence, the world would be unrecognizable. Continents would swing between extremes of heat and cold. Rainfall would vanish. Storms would rage unchecked. Life, as we know it, could not endure. The ocean does not merely support the planet, it defines it, and it holds memory far beyond any human record. Long before there were fossils or bones, the ocean was archiving time and chemistry. The ratio of oxygen isotopes in microscopic shells tells us the temperature of seas millions of years ago. The concentration of certain elements reveals the waxing and waning of ice ages. These are messages from the deep whispers from the Earth to its future inhabitants, telling them what has come before and what might come again. The ocean remembers everything. It remembers warmth and ice, life and loss. It remembers when our ancestors first looked across its horizon and wondered what lay beyond. And it will remember us. Every trace of carbon we release, every plastic fragment, every warming current, all will be recorded, layered, and sealed into the next chapter of its history. To think of the ocean as a mere body of water is to underestimate its reach. It is the planet's builder, its historian, its lungs and heart combined. It sculpts the continents, regulates the sky, writes the climate, and shelters the memory of all that has lived. It is both archive and author, both witness and creator. And through all the transformations of Earth, through shifting continents, changing climates, extinctions and renewals, the ocean has endured. Constant, infinite, alive. It has been here since the beginning, and it will remain long after everything we know has changed. The ocean has always been our beginning, and it may yet determine our end. Every civilization that has ever risen has done so beside the sea. It carried our ships, connected our continents, and fed our cities. For millennia, it was a mystery we worshipped from the shore. Today we've measured its temperature, charted its flora, and traced its currents from orbit, but in doing so, we've begun to forget what it truly is. The ocean is not a backdrop, it is the planet itself, and we are one of its recent experiments. In a single human lifetime, we've altered its chemistry, its temperature, and its life. The ocean has absorbed over 90% of the excess heat trapped by greenhouse gases. That heat expands water, raising sea levels. It melts ice, changing salinity and slowing the great global currents that regulate climate. It disrupts winds, reshapes monsoons, and intensifies storms. The very engine that has kept our world stable for millions of years is beginning to change rhythm, and we are the cause. Carbon dioxide dissolves into seawater, forming acid that eats away at coral and shell. Rising temperatures push marine life toward the poles, disrupting food webs that evolved over millions of years. Overfishing has emptied vast regions of life. Plastic now outweighs plankton in some coastal waters. We've extracted minerals, oil, and sound, leaving scars both visible and invisible. The ocean endures, but it is not untouched. And yet, even in the face of change, it continues to give. It still moderates our weather, provides our oxygen, and stores our waste. It remains the planet's great stabilizer, even as we test its limits. No matter how advanced our technology becomes, we are still creatures of its design, products of its chemistry, governed by its climate. The more we learn about the ocean, the clearer our reflection becomes. Its currents mirror our circulatory systems. Its rhythms resemble our breath. Its capacity to adapt, to find equilibrium in chaos, mirrors our own struggles to do the same. The ocean story is not separate from ours, it is ours. We are made from its elements, sustained by its cycles, and bound to its future. When we speak of saving the ocean, we are in truth talking about saving the conditions that make our existence possible. The ocean doesn't need rescue in a sentimental sense, it will persist regardless. But whether it remains a cradle for complex life or a monument to what once was depends on us. In the deep sea, where sunlight never reaches, hydrothermal vents continue to create new ecosystems, new forms of life, new beginnings. That same creative impulse exists within us. We are capable of destruction, yes, but also of renewal. For every reef that bleaches, there are scientists cultivating corals in nurseries and replanting them. For every polluted coastline, there are communities restoring mangroves and seagrasses that pull carbon from the air and shelter fish once thought lost. The ocean's capacity for recovery mirrors our capacity for change. Both depend on time, persistence, and humility. In recent years, we've begun to glimpse what cooperation with the sea might look like. Offshore wind farms harness its energy. Algae and seaweed farms offer sustainable food and biofuel. Marine protected areas allow ecosystems to rebound when left alone. Even the carbon stored in ocean sediments, what scientists call blue carbon, is being recognised as one of the planet's most effective forms of long-term climate storage. When we work with the ocean instead of against it, it responds. Life returns, currents heal, balance begins to restore itself. But more than solutions, what we need is perspective. To understand that we are not separate observers standing at the edge of the sea, but participants within it. Every breath we take connects us to phytoplankton drifting miles offshore. Every raindrop, every gust of wind, every meal we eat is a consequence of something the ocean set in motion long before us. It's easy to think of the ocean as vast beyond consequence, too big to harm, too powerful to change. But we've already changed it. And that realization should not lead to despair, but to understanding. Because if human activity can reshape the chemistry of a planet, then human intention can shape its recovery. We are, in a sense, the ocean becoming aware of itself. Through us, it studies its own patterns, names its own creatures, measures its own depth. We are its consciousness made temporary the brief moment when the planet looked inward and realized it was alive, and that awareness carries responsibility. To explore without taking, to understand without conquering, to exist within the same cycles that created us. If we can learn that lesson, the ocean will not just survive, it will continue to create, to balance, to remember. There is a quiet kind of hope in that idea. Not the hope of control, but of coexistence. Because for all our progress, we are still bound to the same physics, the same chemistry, the same flow of water that has governed Earth since the beginning. We will always be creatures of the tide. Someday, long after our cities have changed and our technologies have faded, the ocean will still be here moving, breathing, renewing. It will carry traces of us, just as it carries traces of the life that came before. And somewhere in its depths, future life will arise from what we leave behind. That is the way of the sea transformation without end. We began this journey with a paradox, that we have better maps of Mars than of our own ocean floor. Perhaps that's fitting. The ocean does not need us to map it to exist, it needs us to remember that we belong to it. When you stand at the shore and look out toward the horizon, you are not staring into emptiness. You're looking at the living memory of the world. You're looking at the reason you exist at all. The ocean is not Earth's last frontier, it is its first and its forever. If you enjoyed this journey, consider subscribing to Omni, where we explore the hidden stories of science, nature, and the universe. Every like, every comment, and every share helps these ideas reach more curious minds. Thanks for watching, and as always, stay curious.